The more you're doing that, the stronger you're getting at finding where the letters are. And imagine all those pathways in your head being made stronger and more deep. That's amazing. So what are we looking at today? Today we're looking at atomic structure. Okay, so what did I say we're going to do today? Today we're looking at A, T, O, M, I, C, atomic, S, T, R, U. Great job. What are you doing? Great. Up to your C. Up to your C. No, keep going. Up to your C. C, T. Keep going. U, R, E. Fantastic finishing there. That's right. We're looking at the atomic structure. Now we learned yesterday what about the atom? That it's very much empty space. So very much the atom is full of empty space. We also learned yesterday that there's something in the middle called a nucleus. What we didn't learn was inside the nucleus, let me help you with this. So we have an atom, and outside of the atom, and inside we have the nucleus. Inside the nucleus we have other little particles. We call the coloured ones protons, and then the clear white ones are neutrons. So within the atom, or inside the nucleus, there were two particles, and they are called, they are called P, R, O, T, O, M, proton, and the other one is called a N, E, U, T, cold, R, O, N. Fantastic. A neutron and a proton. Now, from the name proton, can you guess whether it is a positive or a negative charge? Yes, exactly, it's a positive charge. And what about the neutron? Do you think that has a charge or no charge at all? So do you think it has a charge or no charge at all? No, exactly, it's neutral, which is where the word comes from. And what you have inside the nucleus is the same amount of numbers of neutrons and protons, so they actually balance each other out. No, that's wrong, sorry. So they actually, you'll always find that the nucleus is in a positive charge. Sorry, I'll recap that. So inside you have the same number of protons and neutrons inside the nucleus, which means that the nucleus is always positively charged. So inside the nucleus, the protons and the neutrons are the same. Change my question around. So what do we know about the protons and neutrons, about the numbers of them inside the nucleus? They are the S, A, M, E, the same. same. N U M B E R. Exactly. Well done. They're the same number. So this means that overall the nucleus has a charge that is P O S I T I V. Great, go for your E, finish off your word. Go for your E, finish off. A positive charge, fantastic. Okay. Okay, we learned yesterday about the neutrons that are around the outside of the atom, outside on the edge. Basically, you have the same number of oh, sorry, Christopher. Where am I? So a proton is a positive charge, and an electron is a negative charge. So you always have the same amounts of protons and electrons in an atom, so that it's always balanced. So the important thing is to have the same number of electrons and protons in an atom, so that the overall atom is B A L B L L B A L A N C E.
Mama.
See, finish your word. Finish your word.
Mama.
Yeah, she's gone to get the car. So finish your word. Just pointing was great. Then go for your D. Finish this word off. So it's always balanced. Okay. And it's balanced because the proton is a negative charge. And okay, so the structure of an atom has the nucleus at the centre, which is filled with the same number of protons and neutrons. And because the neutron doesn't have any charge, and the proton is positive charge, the nucleus is positive charge itself.
No.
I know. So you'll feel better. Better now you've had that plaster put on.
No.
Yeah, leave the plaster on, okay? Yeah, we'll leave it there. Yeah, Mum said no, don't touch. Yeah, I know. We'll know for next time not to touch glass, won't we? Because it's so dangerous. Okay? And around the outside of the structure of the atom you have electrons, and you always have the same number of electrons as you do with protons, and that makes the atom balanced. And that's because electrons have a charge that is N-E. Well done. Hey, can you sit back down? soon. You've got your plaster
I've
on.
had it.
Yeah, probably 5 minutes, I would say. That's it. Have a seat. So you were just telling me that the charge electron has is Ne. I know. Leave the plaster on, don't you? Yeah, is it better? That's it. Ne. Let's concentrate on this, take your mind off it. Ne. G. A. T. T. I know. T. I finish off. N. E. G. A. T. I. Sit. Go for your V. Use your left hand if it's easier for your hand. Go for your V. Move on. Let's get this to there. The electron has a charge that is Ne. I. Go for your V. V. E. That's negative. And in the atom, the same amount of protons, you have the same amount of electrons. Now, so for example, in a carbon atom, there are 6 protons, therefore there are 6 electrons. And in an oxygen atom, there are 8 protons, so therefore there are 8 electrons. Okay? So if I told you there were 8 protons and 8 electrons in this atom, you'd know that the element would be... O, X, I think we want the X. X, go for you. X, keep going. No. Hey, we're going to concentrate for 5 more, okay? Mum's doing her job. And I know you're thinking about your hand. Your hand will feel better at 5. Better to concentrate. So an element that has 8 protons and 8 electrons we know is OX. Use his hand. OX, Y, G, E. And it's oxygen, that's right. Now did you know that also, as well as the proton number is also known as the atomic number. So the number of protons inside the nucleus is also the atomic number, and each element has its own atomic number, and that's what the periodic table is based on. So the periodic table is based on the elements. A, T, O, A, T, O. Well done, this is really great. A, T, O, A, T, O. Up to your M, that's it. Go for your M. A, T, O. I know, you're going to be fine. M, I, C, the atomic, brilliant, keep going. Is arranged according to the atomic. N, Plaster for that one. Come on, let's get you a plaster for that. There's some in here. Christopher, come here. Well done. Hey, this way. Show you when we've got your plaster on there and then carry on. You're just telling me that the periodic table is actually based on the element atomic NU. NU. Doing really great. I'm really proud of you. Okay? The periodic table is based on the NU. Christopher, leave that on, otherwise you can leave that on, it needs to heal. NU. Do you want to do it on the bed? Do you want to sit on the bed? Okay. Come on then. You sit on the bed. You have to sit forward, okay? Christopher, come and sit down. Sit. There we go. Well done. So it's based on the atomic NUM. I know you want the B, I know. You're doing really great. Well done. Let's finish this up. You're doing really great. So the periodic table is based on the atomic NUM. B, go for E. Go for E. That's it. E.
Okay.
E. Finish off your word. The atomic number, that's right, which also tells you the number of protons, and it also tells you the number of electrons because they're the same. So it's a really important table. You read it left to right and down, just like you would read in a book. And you can find out the atomic number of an element by looking on the periodic table. So, what's one thing you can tell me that I've just told you about the periodic table? I-N-T-I-T. Where do you want to go? G. We're just gonna, we've got this number, one non-question at numbered. G-O-E, 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 S, it goes, L, hold it, L, E, F, L, E, F, T, L, E, F, T, T, O, goes left to R, I, G, H, T. Fantastic. Okay. When you look at the atomic number on the periodic table, writing a children's book about science, about atomic structure, how would you simply describe the structure of an atom for children? Say, 10-year-old children. How would you describe it?
Oh, I know.
We don't see, we're just on our last part, aren't we, in our long question. How would you summarise the structure of an atom? How would you explain it? So start off, the atom. Let's go. Leave that there because it's got to heal. That's how it needs to heal. Otherwise you need to come in. So B, T, H, E, the atom, A, T, O, and the atom. I'm really proud of you, so proud of you. S has
Oh, I know.
Yeah, we're just going to finish this off. The atom has P. Oh no. Do this together. Come on. Do really, really well. I'm really proud of you. Let's sit up and keep going, okay? The atom has P.
Yeah.
In a bit, we're doing this. Has P. Keep going. It's really good. Just give me some squeezes, okay? Has P. R. Fantastic. Has P. R. We're going to finish this up and then you can do your choice, okay? P. R. O. T. O. Okay, doing great, doing great. I think you want protons. Go on. S, yeah, has protons. The atom has protons. A, N, D, and protons, and the atom has protons and really, really proud. See, you're staying so calm, doing so good. Okay, so the atom has protons and N-E, well done. N-E. Keep going. N-E. N-E. The atom has protons and N-E. U. T. R. O.
Oh, I know.
Yeah, just one.